I am the eclectic doctor. My interests are various, and where they intersect is where I love to be. So my phrase, code to test, is just a riff off of David Thomas and Andrew Hunt's test to code philosophy. It comes out of this book here. It's the Pragmatic Programmer. It's an excellent, excellent book. I highly recommend it. It's a kind of a philosophical approach to mastering the art of coding. When I read through that book, I find lots of nuggets of wisdom and insights that are things that often that I learned the hard way. Thomas and Hunt seek to dispel the idea that most of my students have about testing their code. They see testing as primarily a way to find bugs in their code. A better understanding for creating tests is as a tool to see, or better to verify, what your code does. This helps you to formulate tests easier, and Thomas and Hunt remind us that it is the thinking about testing that drives how we code in the first place. So if we know that we're going to test, then we code in a way that we're going to be able to test it, to be able to verify things. Testing initiates a kind of a feedback loop between you and your code that makes sure that your units of code are doing what you expect them to do. Now, bugs will fall out of this process, but if you test to see what the code does, then you're better equipped to know why your code is buggy and maybe even have a good idea of how to fix it. So one approach that I find helpful is to write test code as you write your code. If your code is organized well, then you can employ a strategy of unit testing. Unit tests are extra small blocks of code that you write to verify the behavior of discrete blocks of code in your program. So in my ARM assembly classes, I would have the students build a library of string functions. They do handy things like print the strings out on the console, change the case of the strings, or even count the number of characters that are in a string. When we would build this library, I would also have them build tests that verified each of these string functions. We could call the test code to run on the string functions to ensure they did what we expected them to do. This way, when something did not quite work in their program, they could invoke one of these tests to see if the values are working the way that they expected them to be working. Now, the hard sell is that this seems like so much more extra work, but really it isn't. Considering that I often have students come to me telling me that they spent the entire night working on code that's clearly broken, and then I look over it and I see a lot of things that should have fallen out if they had been testing along the way. At least long before the hacking started, and the code just gets worse and worse. And this is the nature of coding too, is you have this, once one thing is broken, if you keep going, then it will cascade. And when you try and fix something, you're going to break something else that you thought you had working. And so it's better to actually get it right. I get the frustration because sometimes I have to tell them they should start again. And my advice is to take the code that they've written, copy and paste it somewhere else, start a new file, and then copy in just each section, test it, and then you can usually rescue some of the code that way, but starting again is where you have to start, and often they will resist that. But the reality is that we all can get caught up in just coding and begin to try and make things work and figure that we can kind of plow through it, holding everything in our heads. But the reality is that it is much faster in the long run to do it right. Short-term pain for long-term gain, or as some have wisely said, learn to work smarter, not harder. The added benefit of testing as you go is that it is often these tests you write that can actually be turned into the unit tests, which can be run against your code each time you change something. So we can be certain that we haven't introduced a flaw that will eventually cause us more grief. So we can build these tests as we go. One approach I champion with my students is to test as they code. As you code a block, based on your pseudocode, go in and make sure you have something that can test that. I want to do a little example, and I don't want to be too worried about the syntax of the language. I just want you to see the process, and then we'll talk about some of the things that we'll do as we go along. And we'll actually build this program out, probably in a couple different languages, using some different tools to see how we can improve that. Inside, my wargame.c program that we started with before, and it had this first part of our problem that we need to solve is to create a deck of cards. Now, I want to actually create that deck of cards. So what I'm going to do is I'm going to come up here and I'm just going to create something that will something that is of type card, because cards have multiple values. They have a suit and they have a valuation. So I'm going to come in here and I'm just going to make them numbers. We'll talk about this much later, how we could make this a little more robust. But I just want to keep it as simple as possible, even though it's not always the simplest to figure out here. And then I'm going to call this my deck of cards. And we're just going to work with a 52 card deck. Definitely we can find lots of opportunities to make this more modular, to be more useful in different ways, but it's a good starting point. So once we have our deck, this is going to be a structure that is basically a chunk of memory that holds 52 sets of 2 values, and they're integers, and it's called an array. And we'll see that when we talk about data structures more in their next video. So, but down here, I want to basically set up initial deck. So I'm just going to write a function that will do that. So the reason why I want to call on a function is because if I write it out as a function and not in my main, then I can treat it separately. So it becomes a logical thing that I can test. And it also becomes something that I can work on to make useful for all of the different ways that I have to construct decks. But this is going to be for my initial deck, so it'll probably be fairly similar. So I'm going to keep this also simple here. I'm not returning anything from this function. Set up initial deck, and I need to write the function itself. So what I like to do is also start by commenting. So in here I'm going to say creates, or actually we're going to say adds a standard 52 card deck to deck of cards using 4 suits and 13 values. So if we think about it, ace up to 10, and that's 10, and then we have jack, queen, king, so that's 13 values. So I'm going to actually turn this into a comment here. I'm going to use these because I'm actually writing it in standard C, just ANSI C, just because I want to just work with something that's pretty standard here. So inside this, I need to do a couple of things. One is I need to put in the first group of them, the first 13, I'm going to put the value 1 for the suit. In the next 13, I can put the value 2 for the suit. So I need a value that can go up, and I also need a value that can go up for the cards that I can reset each time. So what I'm dealing with here is a kind of a looping structure where I'm going to loop through the suits, and inside I'm going to go through each of the cards. It makes more sense than going through the cards. You kind of want to do the smaller one on the outside, just for this purpose. But I mean, you can make it work either way. You're going to get all of them in there. So I'm going to put them in there, and because I need something to iterate through it, I'm going to just use a classic iterator. In fact, I'm going to have 2 because I need 2 of them. And we'll see that I'll need another variable, but we'll get that in a second. So I'm going to say I equals 0, actually 1, because we want to go 1, 2, 3, and 4. So whatever we set it up, spades, we'll work that out in a bit. In fact, what I would do is I would define those or enumerate them in some way. But I'm just going to go I is less than, and I want 4 of them. So I want to go 1, 2, 3, 4. So if it's 5, I want to stop. So as long as it's less than 5, I'm going to keep going. And then I'm going to go and increment that. So that's my outer loop. And then my inner loop is going to be similar. I'm going to go j equals, j equals 1. And with same logic, j is less than 14, j plus plus. So this will only run for once for every time inside here. This will run the full loop. So it'll start at 1 and go up to 13. And it'll do it 4 times. 4 times. So in here, all I want to do is I want to set up that deck. So I'm going to say deck of cards. And because it's an array, I have to tell it which one. I have 52 different places, and they start at 0. So it's just a funny thing with arrays. So I'm going to go up here, and I'm going to build something that I can use. I'm going to call it deck offset, and I'm going to start it at 0. So I'm going to go down here, deck offset, and then I'm going to grab the suit, and I'm going to put I in it. Then I'm going to go deck offset, my deck of cards, deck offset dot, and you'll see it comes up. Lots of the code editors are really helpful this way. But we're going to put j. J is our big number. And then when we're done, we're going to go deck offset. Now I could, some of you are probably thinking, oh, I could just combine these, and I could. It's not a problem. But that will put the values in, and when I'm done, I'm just going to return. It's always just nice to cleanly code that. And I can quickly come out and see, I'll save this, I can see if this actually compiles. That's my first way to test. I like to compile often because then I can deal with things before I even go into writing the test. But I've been thinking about how I'm going to test this as I've been writing this function. So in here I'm going to go GCC, which is I'm going to compile it. You don't need to worry about these, but I'm just going to use some things that will catch errors and make sure that my code is strictly adhering to the NCC standard. And I called it wargame.c. So I didn't get any errors, and if I run A, it runs it, but we can't see if it worked or not. We just have run it. So I could go in and use a debugging tool, but you know, it's better to have a test that I can call on repeatedly that will work for this. So what I'm going to do is I'm going to close that for now, and I'm going to think about writing a test. And I'm just going to write something that goes test deck, and this time I'm going to send it my deck. Deck of cards. So I'm just going to send it the deck of cards. Now we know that the deck of cards is an array here. So I'm going to collapse this. This is another nice thing about a lot of modern editors is I can collapse them, and then I can write my little testing code. I just want to print it out on the screen so I can see what's there. That's the simplest way to test things. Now, you know, I'll be able to invoke this because I'm sending in a deck. I can send in my little decks. I can send in whatever. I can send in a hand of cards. It will work no matter what. It allows me to make something that's more flexible. That way I only have to write one test, and it'll be able to test many of the things that we're working on. So here we're going to call it test deck, and we need to tell it what it's being given. And it's being something that is an array of struct cards, or struct card types. So I want an array of that. So we're going to go, we'll just call it deck. And we'll put the square brackets around to indicate that it is, we're just going to put our return here, that it is basically looking for an array. So I'm passing it an array. I'm actually passing around addresses, but we'll deal with that later, much later. Actually, that would be something to think about if you're going to work in C. You would need to think about a lot of that in some of the languages that you'll work with. Okay, so in this case, though, what I'm going to do is I'm going to write my comment. So I'm going to say print out each of the cards, the deck. So here's where I would probably want to have, something where I could send in the value also of how many cards are in the deck. But right now I have 52 cards, so I'm going to leave it like that, and we'll look at how we can improve these as we go along. So I'm going to come in here and I'm going to go int I, and actually I can start it at 0 because I want to go through each of the cards. And what I want to do is I want to put into each one of them the values. Well, this is my offset. So let's go offset, what do we call offset in deck? I need to be able to go through and just print out what's in each one of these. I'm going to loop through the whole structure itself. So I'm going to go int or offset in deck. Well, equals 0. We'll just do that here. Just make it cleaner. Offset in deck is less than 52 because I'm going from 0 and I want to get 52 cards. So I have to account for the 0, and then I'm going to go offset in deck plus plus. Create this, and then all I'm going to do here is I'm going to go print f, which is print function, and in here I'm going to put a square bracket, and I'm going to say put a number, comma, a number. So I'll use one for the suit, one for the value, a comma, and we'll just put a space. And then I'm going to tell it what I'm going to print out. So here I'm going to go deck, offset in deck, dot suit, and then we're going to go deck, offset in deck, dot value. And I'm also going to do this just so that we can see the code much easier. And I need a semicolon at the end of that. And then when I'm done, just so I'm on a new line, I'm going to go printf. Just put a new line character up on the screen. So this will run through my deck and it'll print out each character. I can call it here, I can shuffle them, call it again. It should show me the shuffled deck of cards. So I'm just going to save this, bring this up, and I'm going to go GCC, run this again. Ha, no problems. And we run it and boom. We have it flowing over, but we have 1 for the first suit, we have 13. For the second one, we have 13. So we can see that all the cards are here. We could also have it print out a count of the cards. We could have it so that it would, so we could see that it's giving us the data that we want. Especially when we start to pass it decks of cards or hands of cards that are smaller than the full deck. And that way we have something that's extensible, or something that we can change and make it to work with jokers, or make it to work multiple decks, or maybe just a partial deck, so that you can play all kinds of different games. We're just trying to open up those pathways for this. But what I want you to see is that now I have a test that I can use in multiple different areas, and it's great. I can just comment out these when I don't want to use them. So when I'm done, if I don't want to test it, I can do that. And I can even take that test and copy it around. So it gives me a lot of flexibility. So I'm going to save this and I will put it up and you'll be able to play with it. I love playing instruments and I'm okay at a bunch of different ones. But what holds me back from being great are the habits I've learned along the way. And I know this because every couple of years I go and take some guitar lessons or some piano lessons, and I realize the bad habits that I've internalized. And I also catch a glimpse of how good I could be if I just spent more time on one instrument fostering good habits. But I don't make my living playing music. So it's harder to take the time to internalize the good habits I know would help me. And I find a lot of coders also follow this same pattern. There's a little more at stake when you're choosing a career and something that you're really a hack at doing. And I teach for a living. That is my primary skill. And in teaching, you need to foster good habits. I need to learn to pace myself in the classroom. I need to make sure that I'm not too proud to admit my mistakes. In fact, teaching programming is a very humbling experience when you do live coding in front of a large class of students and you are trying to trace down a simple typo. You need to be easy on yourself. I need to make sure that my instructions are clear, my board work is clean, that I have all the tools to keep my ADHD brain from taking me off down too many rabbit holes. I'm far from perfect at these things, but I work at it because I know these are essential to my livelihood. Being a programmer has its own set of good habits as well, and these are the things I want to foster the most in this series. I believe that these habits turn into skills that let you not only program faster and better, but they also set you up for success, working with a team, working on your own, and they're harder to develop later. It's hard to break those bad habits once they're internalized. I started this series talking about problem decomposition. Find a way that works for you and stick to it. One of my great friends enjoys flowcharts with all of the other formal UML tools. Great. Each tool helps you see a different part of the project. For teaching, I prefer to build pseudocode in, or what we call a simple algorithm, that you can drop right into your code, as I've shown you, so that the students can see where we're going. However it is that you do it, make sure that you spend time breaking down your problem. And when you get stuck, break it down further. This is your go-to process instead of hacking away at the code with no plan. Write your code cleanly and consistently. You'll notice that I get really picky about spacing and those sorts of things. I want my code to look clean, to read easily. I want my variables to be named consistently. My students often ask me about coding practices like this, and I tell them that they should expect to adapt to the coding standards of their workplace. But in their submitted assignments, I'm looking for consistency and readability. If you're consistent and you go for readability, you can usually adapt to any style guide. The other thing to notice, as you probably saw, I was able to move one command down onto multiple lines. In many languages, spaces, tabs, and return characters are all treated as a single space. The big exception is when they're within quotes. So that means you can space out your code to make it readable. And your future self will thank you for clean, readable code. So many times students will come up for help and there are few or no comments in their code. And they have spent many hours hacking at the code and they're certain it's correct. Consider that this means hours of holding a bunch of variables and functions in your head trying to weave together your code. And this is fine for small problems, but the first time you have a complex problem to solve, it just leads to frustration. Often when they come to me, there are fundamental problems with the code that require a complete rethink. Without comments and good organization, it is almost impossible to fix the code. This is the risk of making comments merely an afterthought. If the code was well documented and set up in discrete blocks, you can often avoid a complete rethink, especially if you can test those discrete blocks to make sure that you know what they are doing. And pseudocode is my favorite solution for this problem. I try to make it a habit that when I create a function, I at least add a comment that tells me what it does, if not, what it expects and what it sends back when it's done. Those three simple questions at the start of the function can make a world of difference when you're trying to find a bug in your code base. It is easy to code something in a strike of brilliance, only to return to it a few days later and have no clue what that bit of code does. Even if it works, you have to kind of work your way through it again. This is why when you comment after, it's not going to match your code, because you have to reparse all this code again. I have a video on commenting, and I'll link it here, and we will talk about commenting more in this series. And as you likely expected, my final advice is to test often. I like to test every step, or at least as soon as I can test something. This way I do not get too far into the code without knowing exactly how each block of code behaves. And a bonus here is that testing requires saving our files. That's something that you cannot do too little. You need to save your files. That'll save you a lot of heartache. So hopefully I've convinced you to start building good programming habits. Next up, we're going to start to get into some more nuts and bolts, and we'll talk about variables.